All right, so moving on to the very last example. This time we're asked to identify the parent function, describe the sequence of transformations from f to g. Sketch, it says track 1 point, but I'm going to track multiple points, and then use function notation to write g in terms of f. All right, so for part A, right, if you kind of inspect, right, the parent function is just 1 over x. Okay, so if you're wondering, it's like, what is the parent function? There's a video in, I believe in lesson 1.3 or 2 where I went over all the basic parent functions. Okay, so you might have to go back and study that. It's also in your math analysis textbook. All right, so there's part A. There's 1 over x. Part B, I'm asked to describe the sequence of transformations from f to g. Okay, so if you take a look, right, how is these two functions different? FYI, right, this is the general form of any rational function. We will call it h of x, 1 over x minus h plus k. Okay, so you may have studied this in the past. If you haven't, this number down here, right here, shifts it horizontally. This shifts it vertically. Okay. By the way, this should be, you can call this, you can also insert an a over here. You actually put this as an a value. Okay, a changes the graph vertically. All right, so just looking at this, right, it looks like it shifts the graph 4 units to the left and then 2 units down. Okay, so if this is the general form, right, h shifts to left and right, k shifts to up and down, a changes the size of your graph. All right, so there's a sequence of transformations, 4 to the left, 2 down. And then for part C, right, we actually have to sketch or track some points. So before we track some points, let me again label. Here's my x, here's my f. If I plug in 1, I'm going to get 1. If I plug in -1, I'm going to get -1. By the way, right, your graph's going to look something like this. Right, really roughly, there's 1, comma 1. -1, -1. Okay, so we'll go into detailed graphing rational functions later. I mean, the point of 1.4 is just transformations. So those are the points that I get from my graph. And just like I did in the previous video, right, because I'm shifting it 4 units to the left and 2 units down, you can basically state that for the x values, I subtract 4, and then for the y values, right, I subtract 2. All right, so for my g, if I take 1, I subtract 4, I'm going to get -3, -1, subtract 4, I'm going to get -5. And for 1, if I subtract 2, 1 minus 2 is -1, -1 minus 2 will give me -3. So your graph, after you get the transformations, right, those points become like this. So -3, -1 somewhere, I guess -3, -1 somewhere over here. And then -5, -3, -5, -3. Okay, actually, maybe I should draw some tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, so -3, -1 is somewhere over here. And then -5, 1, 2, 3, 4, 5. -3 somewhere down here. Okay, so your graph, right, is going to look something like this. Right, that looks like it got shifted 4 to the left and 2 units down. Okay, so later on I'm going to show you officially how to graph something like this. You basically have to find the vertical asymptotes and combine this into a single function. Okay. All right, so moving on to part D, you're asked to use function notation to write g in terms of f. Okay, so use function notation to write g in terms of f. Okay, so remember, all I'm doing right now is shifting the original graph of f of x 4 units to the left and 2 units down, right? So 4 units to the left, right? basically I have to write x not plus 4, or sorry, not minus 4, right? X plus 4. And if I have to shift something down 2 units down, right, all I do is write a k value right here, which is minus 2. And that's it. Right? If you take a look, right, if you go back to your original parent function, if you plug in f of x plus 4 into this function, right, you're going to get 1 over x plus 4, and then subtract 2, you end up with originally your g of x right here. Okay, so it's kind of like the opposite of what we just did. This time you have to write the function. All right, so I'm going to skip number 9. I'll say that as a try. I'm going to move on to number 10. And number 10, you have a cubic function. G of x is negative 1/2 x minus 3 cubed plus 1. All right, so I already kind of gave away the answer to part A, right? What is the parent function? You would say the parent function, Mr. Zhu, f of x is just equal to x cubed. Okay, how do I know? You know, somebody in my math 3 class asked me, it's like, Mrs. Zhu, I'm not quite sure how you got that. You kind of just have to look, right? This is a cubic function. Over here, right, this is a rational function, right, because there's a variable in the denominator. So I know sometimes that's a little bit tricky, but you have to look at the original function and see if there's a cube there, if there's a square there, it's a quadratic. If there's a square root, it's a square root function, okay? All right, so moving on to part B, describe the sequence of transformation. So this kind of just looks like our general form, right? And it is. So the absolute value of A, right, this number changes the size of the graph, vertical shrink or compression, factor of 1/2. A is also less than 0, so it's a reflection over the x. And then 3 units to the right, 1 unit down. Or sorry, 1 unit up, I should say. Okay, so 3 units to the right, comma, 1 unit up. All right, once we get that, right, on part C, we're going to sketch. And even though it says track 1 point, I'm going to track 3 points, okay, because otherwise it's kind of hard to tell, you know, how do we sketch it. So if you plug in f of x, right, your parent function looks something like, well, let me plug in some points first. We'll call it 0, 0, 1, 1, and if you plug in negative 1, you also get a value of negative 1. Your graph, you know, is going to look something like this. Zero, 0, 1, 1, negative 1, negative 1. You can plug in 2, 8, negative 2, negative 8, but roughly there's your cubic function. Okay, so I'm going to track these 3 points on my table. And just like what we did before, right, what do I need to do with the x values? Well, the x value is impacted by what's inside the parentheses, right? If you look at G, right, all I'm doing is shifting it 3 units to the right. So the x values, all I need to do is add 3. And what do I do with the y values? Y values are impacted by what's on the outside. I have a negative 1/2 here. I have a plus 1 over here. So I'm going to multiply by negative 1/2. And then I'm going to add 1. Okay, so problem is very, very similar to previous examples. And hopefully this stuff is starting to make sense. Here's x, here's g. X values, if I add 3, I'm going to get 3, 4, and 2. And y values, if I multiply 0 by negative 1/2, I'm just going to get 0. And if I add 1, I get 1. 1 times negative 1/2 is just negative 1/2, or negative 0.5. Negative 0.5, negative 0.5, add 1 is 0.5. And I have one more point over here. Negative 1 times negative 1/2 is positive 1/2, right? And positive 1/2 plus 1 is 2.5. All right, so that should give you the coordinates over there. Oh, actually, I'm sorry, I made a mistake here. Negative 1 times negative 1/2 is positive 0.5, 0.5 plus 1. So this one right here should be 1.5. Okay, so let's plot it here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 3, 1 will be somewhere over here. 4, 0.5 would look something like this. And 2, 1.5. 2, 1.5 would look something like this. Okay, so the graph roughly is going to look something like this. Right, because remember, it got reflected over the x and the y. And it also got shifted 3 units to the right and 1 unit up.